Hello friends, welcome you all. In earlier videos, we discussed the concepts of how do we represent Turing machine. Hope you know the concepts. If you don't know, then watch my earlier videos. As we discussed that there are three ways to represent Turing machine: instantaneous description, transition diagram, or you can represent Turing machine by transition table. By instantaneous description, we have already discussed in earlier videos, and here we will see how we will represent Turing machine by transition diagram or transition table. Before discuss these two representation, we will see here formal definition of Turing machine. As PDA is defined by 7 tuples, Turing machine will also be defined by 7 tuples. So here we have 7 tuples for Turing machine. As we discussed in the PDA, there were 7 tuples there also. Just correlate by DFA. In DFA, we define DFA by 5 tuples, and in PDA, we define PDA by 7 tuples. 2 extra tuples were there in PDA, and here also 2 extra tuples than deterministic finite automata. Q represents the finite non-empty set of states. So this will have many states. We can say that Q is the set of all the states. This is the input symbol or non-empty set of input symbols. As we can take either A or B, by what you can represent the language. Here is the new tau symbol. As we discussed in the push down automata, tau represent the stack symbols. Here this is tape symbols. So B is the blank symbol, that is the part of B is the subset of tau, or B is the element of tau. This is the transition mapping function. In deterministic finite automata, it was representing that we are going from one state to another state. Same concepts are here. This is taking one internal state, suppose that Q, reading the symbols from the tape, going to the next state or on the same state, and writing symbols, and movement of the head, either it will go left or right directions. We will give one example so that it will clear. So just take one example for transition function. Just understand the concept of transition functions. Suppose that here 0, 1 and all are blank symbols. So this is our read write head, and initially this is on Q0 state. Suppose that transition function on Q0 reading the symbol 0. It is producing that Q1 and writing 0 with X and going in right direction. So what will happen at the place of 0? 0 is read, but it is written by X. So now read right head will go here. So suppose that at state Q0, read right head is pointing or representing 0 symbols. After reading this symbol on the cell, Turing machine will write also. And after writing, head movement will either go in left or right direction, or state might be changing. So this is the definition of transition mapping in Turing machine. Initially this is on Q0 state. After reading symbol 0, this is going to Q1 state and writing 0 by X and moving in the right direction. So we read 0 and 0 is written by X, and head movement is going in the forward direction or right direction. So this is the definition of transition function. Friends, we will understand the concepts of transition function or transition mapping by the help of this example. How transition is moving from one state to another state. So here we have string 001 and B is representing the end of the string or blank symbol. So Turing machine will computing this string and it will find blank at the final state. Then we can say that this string is acceptable. So here this is saying transition function at Q naught. Whatever symbol, if we are consuming 0, then it is saying that 0 is written by 1 and on the same state. So Q naught and 0 is written by 1 and moving in the right direction. So this is the meaning of this transition. On Q naught, reading symbol 0 and writing 0 by 1 and moving in the right direction. So here on Q naught we are reading symbol 0 and 0 is written by 1 and we are still on Q naught state and read write movement is going in the right direction. So now it will point 0 and 0 is written by 1. Now if another 0 is coming, this is on the same states and 0 is once again written by 1 and moving in the right direction. So now read write head movement is pointing to 1. Now what is happening here? If at Q naught reading 1 then going to Q1 state and 1 is written by 0 and moving in the right direction. So here 1 is written by 0 and moving in the right direction. So read write head movement will go on the blank symbol. Here Q naught is initial states and F is the set of final states. So friend, in DFA we know that if we have a string, if machine is reading these strings and going to the final state, then we say that that is acceptable or string is acceptable. In case of Turing machine, if machine is computing any strings and that is halt on final state, then we can say that that string is acceptable by Turing machine. So here there are two cases. If Turing machine will halt, then we can say that if Turing machine halt on final state, then that language is acceptable. If Turing machine is halt on non-final state, then we can say that that language is not acceptable by Turing machine. And another case is that if Turing machine is not halting, it means that it is computing, still computing or loop kind of thing, then in that case also Turing machine is not accepting any language. So for accepting, so we have two cases. Either Turing machine will halt, if this will halt in final states, or here non-final state. So there are two situations for halting also. If Turing machine will halt in final states, then we can say that this is acceptable or accepting. If Turing machine halt on non-final state, then we can say that not accepting. Another case is that not halt. It means that not halt is the situation that Turing machine is still computing. So this is going to infinite loop. So hope this formal definition for Turing machine you understand.